specifically, I think this pretty much restricts it to halves. But then we're going to have multiple angles. It could be 2x, it could be 3x, 4x, so on and so forth. So there's little extenuating circumstances whenever you run into those. I do believe there's only 4 examples that we're going to need to work through. So hopefully we'll get done with these in a timely manner. So note on these, we are in radians again. We have 2 sine, and that is x over 2 equals 1. So if you're coming in off of the other lesson, the main difference here is instead of just a regular old x for your angle, it's x over 2. Your angle has been halved. Now, the difference for us in solving is not going to be much different at all. So when your angle has been halved, don't let it rock your world. You're going to solve this thing the same way you've been doing, and it's going to add one little step to the end. Okay? So proceed as normal. The numbers out front, you can work with during the equation process. Anything that is associated with the angle, you must wait until you have your angles. You got to get rid of your trig function first before you can do anything with values on your angle. Let's see here. So we're going to come in here, we're going to divide by 2. And that's going to give me sine of x over 2 equals 1/2. Now, you see it's sine up. My interest now lies in sine. I have to basically do inverse sine of both of these. So where is sine a positive 1/2? Well, sine is positive in first and second. And that would be a 1 and a 2. 1 and a 2. That is 30 degrees, right? Okay, now let's see here. It's not supposed to be degrees, though. We're supposed to be thinking in radians. 30 degrees is pi over 6, is it not? So that'd be pi over 6, and this one would be 5 pi over 6, a little bit right before the pi mark. Let's see here. So is everybody happy with that? Got pi over 6 for 30 degrees and 5 pi over 6 over here to represent 150. Now, here's the new step. I didn't ask for what is x over 2. I need to know what x is. Well, let's just think. How do you get from x over 2 to x? Don't you just multiply by 2? Well, think about it. 2 times this fraction, they cancel each other out and you just get x. Well, 2 times this fraction, it's just going to be pi over 3. 2 times this fraction, 5 pi over 3. Now, I know I've got some of you that really just don't like fractions and you really don't like radians. So let me give you an alternative. We said at the beginning, we said, okay, this is 30 degrees. Okay, work it in degrees and convert it at the end. We said 30 degrees, 150, right? Excuse me, that's x over 2. Well, that means when you come through here and you're like, hey, I don't want x over 2. I need x. Well, go through, multiply by 2. That's 60. That's 300. Convert both of those to radians. 60 is pi over 3. You're supposed to know that one from memory. And then if you figured out what 300 is, that's pi over 3 from 2 pi. So that would be 5 pi over 3. Well, should match, right? Okay, just giving you another option, but one way or the other we should end up with these answers. It doesn't really matter which path your brain goes down, our answers should match. So, there you go. That's the first set. Now let's go to the next one. Again, we're skipping the practice problems. We're just doing the main problems from the text. So this one says we have cosine 2x equals cosine x, and again, we're working in radians. Okay, this one, hopefully you notice that there is a little difference here. It's very slight. On the left side, we have 2x is the angle, and on the right, it's just x. Guys, you can't mix these. You've got to get these speaking the same language. Doesn't matter which way you go, but you've got to break them down. Now, the one you know rules for is cosine 2x. Now, cosine 2x, you have a lovely little rule, and hopefully it's caught your attention that you need to keep everything in terms of cosine here. You don't need to interject another function, because if you throw in sine in any way, shape, or form, it's really just going to mess things up. You have a cosine 2x rule that only uses cosine. 2 cosine squared x minus 1. I do believe that's it. So we're going to take this and we're going to replace it. 2 cosine squared x minus 1. That's what this is equal to. Now I'm going to take, well, let's just go slow. So is everybody happy with this gets replaced? Now this cosine needs to go over, because since I now have a quadratic, I'm going to need to put everything in descending order and get it equal 0. We talked about that earlier. Equal 0 is very crucial. If I can get it factored, then I can work it out and solve. So 2 cosine x and regular old cosine x, two numbers that multiply to 1, it would be 1 and 1. I need the one that matches with the 2 needs to be negative, because this says the bigger one needs to be negative. So that gives me a negative 2 cosine, and this is going to be a positive 1 cosine. So that's going to work out. Everything factors beautifully. I have 2 problems. I just need to set them up and solve them. So the hard part was working out with your substitution rule. So 2 cosine x plus 1 equals 0, and cosine x minus 1 equals 0. This one, I started it just because I noticed it would be an easier problem. When cosine is 1, I'm hoping you realize that that is unit circle. The only place cosine is going to be 1 is at 0. Remember, cosine is your first term, so x equals 0 degrees, and that is all you get there. Now you come over here and you start working. You got 2 cosine x equals negative 1. Divide through by 2. Cosine x equals negative 1/2. Okay, you got to draw it out. Cosine is negative in second and third. Remember, cosine is adjacent, and then we have hypotenuse. So that means square root of 3 to here. This is a 60-degree angle. And I put degrees on this, and we're talking radians. Shame on me. It's 0 radians. If that is 60 degrees, remember that's pi over 3. So if you come back pi over 3, 3 pi over 3 minus that is 2 pi over 3. And then add pi over 3, 4 pi over 3. So we have all 3 of these answers. Okay, now we have 2 more examples that we need to work through. Let's see how this works. Here's the next one. Solve an equation using a multiple angle identity. Okay, so it kind of ties in with the other. Thankfully, they let us go with degrees. They don't let us do that much. Now, we have an issue. I'll tell you what, let me copy this so that it's not embedded in the text. We have an issue with the fact that we have 2 trig functions, and we can't split them up because we don't have it equal 0. So we got to come up with something else to manipulate this using identities to get it back to 1 trig function. What trig identity did we just get finished using that had sine cosine? And think of it like this. Sneaky little thing, right? You could take 4 and you can write them as 2 times 2, right? Then that right there is perfect. So you have 2 times sine 2x equals square root of 3. Now I know I don't need the brackets. I'm just trying to show you how it all sets up and works. so I can divide through by 2. So sine 2x. Now this is where I was telling you, you can't touch this 2 right here. Not until the sign has been addressed. So you leave that alone. We've got to figure out where is sine equal to a positive square root of 3 over 2. Now sine is positive in first and second. So opposite hypotenuse. Opposite hypotenuse. That is a 60 degree and 60 degree there. Well, let's just see. If I do this, that means 60, because I get to count in first quadrant. It's always nice. Second quadrant would be 120. Now, here's a little twist that's kind of hard to remember, but it's a nice little rule. You see this 2x? Let this number here tell you how many rotations you have to consider. We're used to doing the 0 to 360, the first circle, right? Well, we need to do another circle, and I'll show you why here in just a second. Now, go back to coterminal angles. This angle right here, if you add 360 to it, 60 plus 360, that's going to be 420. And then 120 plus 360 is 480. So the blue ones are from your first rotation and the pink ones are from your second rotation. And you may be wondering, why did I do that? Because the instructions said from 0 to 360. Why did you go over? Because, remember what we did with the half earlier? We had to multiply by 2 to get rid of it. You're going to have to do the opposite now. To get rid of this 2x, you've got to come in here and you've got to divide by 2. So all of these values get divided by 2. So 60 divided by 2 is 30. 120 divided by 2 is 60. 420 divided by 2 is 210. 480 divided by 2 is 240. So the resulting answers are in your first rotation. These really are in that first circle, but to get all of the answers that work in that first rotation, you had to look at the first 2 rotations, and that is stipulated by this number here. So if we were ever looking at like sine 5x, you would need to circle around 5 times and write them all down, and then when you divide it by 5, you get them all. So you just got to put a little thought into that. Oops, I was trying to write with an eraser. There we go. Okay, now this next problem says tangent. Well, I don't think we're going to have time for this one. We're going to run out of time. So I think you should be able to do what you need to with the problems we have worked so far. The main thing here is what we have just done with those double angles. So if it said something like cosine of 3x equals, I don't know, 1/2, you're going to need to tell me where is cosine 1/2. Well, cosine's positive here and here. Well, that's going to be a 1 and a 2. This is square root of 3, right? So that would be 60 and 60. So 3x equals 60. And then the bottom one there would be 300. Now, I don't care how you do it. You could just, if you wanted to, what you're really doing is you're adding 360 each time. So there's 420. And you just, 660, you would have to do that again, guys. Okay, I need to wind this up because my timer got started a little bit late. Once you get all of these, you'd have to divide them all by 3. So whatever this would be, they would need to be divided by 3 as well. We'll go over that some more in class.